as we practice territorial acknowledgements, it's important that we take time to listen to and give voice to the ways of our Indigenous people. So here we have Wes FineDay, we're going to listen to him as he describes his people's ways of knowing in the time of spring. I'm going to watch this video together. I'm going to mute myself just for a moment here so that we can get good audio.
And the trees are just getting their green. And you know, in this time of year, when the sap begins to flow from the poplar trees, that's when we were young, we would get taken out to the bush and we would have to find a big poplar and take a chunk of bark off of it. Not around, but up and down, so you don't kill the tree. But then scrape off that inner bark and eat the sap of that tree, because it is medicine for your blood. It's a blood cleanser, plus it strengthens your immune system. After a winter of hardship and starvation, a lot of times you needed to renew your strength, and that renewal came from the land, from the medicines. And so every one of these trees becomes a relative that you can come and visit and call upon. And so who am I? Turns into look around you. I am this and more. The things that you cannot see and the things that you can.
Oh, you're muted still, Hebron.
I knew I would forget that. Thank you. If you have a chance to check out this YouTube video of Wes FineDay at some point, the link is there when it's shared. It is powerful. With this in mind, we would like to begin by acknowledging that the land on which we gather today is the land traditionally used by the Haudenosaunee, Anishinaabe, and Neutral people. We also acknowledge the enduring presence and deep traditional knowledge, laws, and philosophies of the Indigenous people with whom we share this land today. Okay. The agenda for today is we're going to look through some topic timing. We're going to get into topic 11 details through the LRP site. We're going to look at operations with fractions across the grades, rate, ratio, and percent across the grades. Now we're going to look at models for operations with fractions. We're going to talk about using a ratio table to find equivalent ratios, rates, and percents. And then we're going to have time for questions and answers. So we have a packed agenda today. So as mentioned in the just-in-time email, we're going until 5:30 today to give us time to discuss both operations with fractions and ratio, rates, and percents well. So, and we understand you might have other commitments. You might not be able to stay till 5:30 and you want to catch the recording. We totally get it. But just so you're aware, we're going to be going till 5:30 in case you're wondering around 5 o'clock why we're not wrapping it up. All right. We are going to take a moment, like we do every topic, to just share which topic we're currently teaching. This gives us just good data to be responsive, and it's been really helpful. So go ahead and just pop in the multiple choice for the topics that you are in right now. I'll give you a moment to do that, and then we can keep going. All right. Thank you for popping your responses. So topic timing with April break. This is where we're at in our calendar. We are in the consolidation, finishing up topic 10 time potentially, or consolidation time, or if you need more time for topic 10, before we get into our spring break. This is a great time. I'm glad you guys are all here. Just gives us an opportunity to finish things up, kind of synchronize where we're all flowing towards, and then hopefully after spring break, be able to jump into topic 11 together. So that being said, let's jump into what topic 11 is all about. Here we've kind of taken the curriculum digital site and pieced it so we can see everything in one view. So we've got operations with fractions, dealing with addition and subtraction, and multiplication and division. And we have rate, ratio, and percent across 4, 5, 6. We've put in there expectation F1.5 from the financial literacy strand for grade 5s, because it connects with unit rates and best value scenarios. So here is our one-shot snapshot visual. I'm just going to take just a couple of minutes to talk through this. One of the things you'll notice in primary, we've just focused on grade 3 because there's just a lot happening in this visual. In grade 3, in the operations side of things for fractions, they're really working on getting the relationship between the numerator and the repeated addition of a unit fraction. So what's going on with the numerator, just representing the relationships there in concrete ways. You'll notice in grade 4, we're continuing that concept, but this time we're relating it to multiplication of a unit fraction. So 3 1/5 or 3 times 1/5, well, how does it relate? And how can we represent its relationship to 3/5? So making connections in those representations. Again, in grade 4, you'll notice they're not doing any kind of operation. They're just working with representations, relationships, and models. In grade 5, we're going to be adding and subtracting like denominators. So working, this example is in fifths, so 1/5 and 2/5, 2/5 take away 1/5, that kind of scenario. And we are multiplying and dividing in grade 5 one-digit numbers by a unit fraction. So what does it mean when we say 3 times 1/5? There's a connection to what was discussed in those representations, and that the grade 4 representation is going to be pulled into grade 5 as we continue those ideas. And then the idea of what is 3 divided by 1/5, or we can look at it as, we'll look at this further later, how many fifths or 1/5 are there in 3 wholes. And so that's what grade 5 is working on. In grade 6, it gets a little bit more complex. So a lot of the grade 7 stuff classically we've had in our 2015 curriculum, 2005, sorry, curriculum is pulled down into grade 6. So we're adding and subtracting unlike denominators. We'll talk about this further. We're not going to be using, the least common denominator stuff that we've classically used. We'll talk about strategies and models for that later. And we are going to be multiplying and dividing a whole number by a proper fraction. So not just one-digit number, any whole number, by a proper fraction. So 3 times 2, 6. So those meanings that we pull from grade 5 actually apply, 2, 6, and we're counting by 2, 6, 4, 6, 6, 6, right, for multiplication. And then 3 divided by 2, 6 would be how many 2, 6 fit into 3 wholes. So those models are really, and visuals are really crucial, as Michelle will speak to in a few moments. When we get into rates and ratios, in grade 3, they're just dealing with ratios that have that compare same quantity measure, like 1 to 2, right? Maybe we're talking about apples and there's 1 for this person and 2 for that person, that kind of scenario. And then in grade 4, we're moving into rates. And grade 4 is just really representing simple whole number rates. So the only difference is from grade 3 to 4 is now we're pulling in that we have different quantity measures. So we have got kilometers and hours, dollars and items. Notice there's no like half value or decimal. There's not that kind of stuff is too complicated. In grade 4, we want to just get the idea of rates. And then in grade 5, we get into equivalence, where we are comparing rates or ratios and finding equivalent ratios and rates. We're using calculating unit rates now to compare. And then this is where that financial literacy piece comes in, where we're determining the best value or the best buy in financial situations. And then grade 6, it's kind of everything in problem solving, where we have ratios, fractions, percents, rates. Ratios in grade 6 can be more than 2. It's not really properly represented in this visual, but you can have a 3-number ratio. That's kind of the overview of the fractional operations and rate for 4, 5, and 6. I'm going to pause there. Does anyone have any questions before we? All right. If you have any questions, if a question comes up, just pop it down in the chat and we will be happy to address it. Okay, so we are going to jump into some fraction number talks. I would like you, this is a text response, yes. How does thinking about money help you to add and subtract these fractions mentally? So we have 2/5 plus 3/10 and 3/4 minus 3/5. How does thinking about money help you add and subtract these fractions mentally? All right, so if you pop over to the Meet, I'm sharing my screen of what people's responses are. We're seeing connections to the tenths and dimes and seeing the cents value, and then connecting the fifths. 2/5 is 4/10 to tenths, so it means it's 40 cents. So we're making some equivalent fraction connections. Using the money model is helpful, definitely. Considering the denominators as fractions of a dollar, what fraction of a dollar would have fifths, how many fifths in a dollar, that kind of idea. I could think of a tenth as a dime and a fifth as a nickel, potentially, yeah. And I cannot add 2 nickels to 2 dimes and get 4 something, so they do not have the same value. So comparing what they know about nickels and dimes is really interesting. Even that value of a fifth in the denominator is a really good discussion point to be like, oh, okay, how does that connect to nickels? How many nickels would be in a dollar if 1 nickel is 5 cents? And then helping make those connections. Cool. No, that's great. Don't be sorry. That's fantastic. 3/10 is the same as 3 dimes. 2/5 is the same as 4 dimes. Oh, so making that 10th connections is great. No, don't be sorry. That's fantastic. Because I was anticipating that fifth being connected to nickels for students, and it's good for us to experience that and go, okay, how does that connect for them? And how can we make sense of it? Because when they see the fifth in the denominator, usually that 5 is pulled out to being like 5 cents. So a fifth of a dollar is 20 cents. So the working in the hundreds will help them split them up. It's fantastic. So big picture here is, there we go. When we're working with fractions, especially with number talks, there's many different models that we can use to make sense. So what our maybe classical way of looking at fractions, where we've used some rote steps, is to think of a least common denominator, and this is how you add it, do all these steps. That's what you do. And so we want to steer clear from that. We don't want to even talk about the common denominator at all through 4, 5, and 6, because we know that there's lots of models that are just as efficient, but also are super fantastic at developing understanding conceptually. So money is one of them, because it's not only a context that they might have exposure to, it's something that lends itself to fractional equivalency. So they can make a connection and say, oh, okay, if I have a fifth of a dollar, how many pieces of a dollar will give me a fifth? That kind of stuff. The other thing that we talk about is clocks. They're fantastic because looking at a clock, you can actually break it down to pieces with numeric values connected to it, right? So a clock has 12 parts, you know, so if I have that, if my fractional amount is 1 piece, I know it's a 12th. And if it's 2 pieces, it's 2 12ths, which might also give me a 6th. So those visual model connections are fantastic. So what are some of the things we can focus on across the grades? So in grade 4, we want to focus on number talks on unit fractions. So games like Buzz, or I think in French when you're counting. So counting in unit fractions is fantastic. And you might say Buzz, or you might say stand up when you say whole values. So 1/4, 2/4, 3/4, 4/4, people will stand up. Those kind of games kind of help with the fluency of counting with fractions and understanding that whole to part relationship as they're counting. Grade 5, we're mentally adding, subtracting fractions with like denominators, and fraction splats, which you're going to experience a little bit later, are a big part of that. You're doing some mental math with like denominator fractions. Grade 6, you're mentally adding, subtracting fractions using money and clock models, as we've kind of seen, to help you model and represent the fractions that you're seeing. There's lots of great resources for number talks. There's Fractional Fosno, it's the green one, and there is the Parish Math Talk ones, number talks as well, that are also green. I don't know how they coordinated that, 2 different people, but those are, yeah.
Just before you go on, I just want to reinforce for grade 4, when we're counting by unit fractions, we want to make sure we go past 1 whole. We often stop, and then kids get the sense that fractions end at 1 whole. So using Hebron's example, we'll count 1/4, 2/4, 3/4, 4/4. Oh, that's the whole. Buzz, yeah. Or sit down or stand up. 5/4, 6/4, 7/4. Oh, 8/4 is another whole. And you go through your whole class just counting by fourths, helping kids recognize that every fourth
yeah.
is another whole. And that's really important. And then it helps them make that connection. You go around the class 1 whole time, they see that the number of kids standing is the number of holes, and there might be some extra. So making that connection. So Glenda, the game Buzz is very similar. You would say 1/4, 2/4, 3/4, and then that 4th person would say Buzz. And the reason they're saying Buzz is because it's a whole number. And Hebron and I were talking about this. I remember it speaking in French. And it was like if you have multiples of 5, say, you would say 1, 2, 3, 4, oh, Buzz, instead of saying cinq, because it's a multiple of 5. So that's all the game of Buzz is. Thanks, Hebron.
Oh, my pleasure. Oh, and now it's Michelle's
me.
Yeah, it's you.
It's me now. Okay, so Hebron mentioned the importance of money and the clock for context to help students make sense of fractions. And we want to not only provide those contexts or familiar models, but we want to really emphasize the visual, because by emphasizing the visual, the representations that are either concrete or modeled visually, we're helping students make that connection. We're building that bridge so that they can move to the more abstract. But just as Hebron mentioned, we're really reinforcing here that idea of adding and subtracting fractions using equivalence is in grade 7. It's in the grade 7 curriculum. It's lived in the grade 7 curriculum before, and it's staying there. It has not come to grade 6. So in grade 5 and 6, students are operating, which is new, the operations with fractions in grade 5 and 6, but it really is that foundational visual representing what does it look like and making sense of those operations with fractions. So it's not about an algorithm or a strategy to make it quicker. It's about developing that understanding. So we saw that Steve Wyborney's splats, we saw them back with our algebraic thinking, developing algebraic thinking. He also provides some fraction splats. And although this still develops their algebraic thinking, for us, when we're thinking about it with grade 4, what we want to do is help students, because grade 4 is the first time they're seeing fraction notation, the symbolic fraction notation. So how would you, if you presented this particular fraction splat, how might you symbolically represent student thinking? So think about what might your students say when they're looking at this fraction splat, and then how might you represent it symbolically to help students make the connection between the visual and the fraction notation. And we'll ask you to pop that into your Pear Deck, recognizing that Pear Deck is not going to, because it's a text slide, it's not going to make fractions easy, and you'll have to use a slash, which, you know, normally we frown upon, but we're just going with the technology we have here.
We have no choice.
So Hebron, if you can give me a sneak peek at some of those responses. Thank you. So I'm seeing some good detail about what you might represent based on what your students are saying. So even as simple as, okay, I know that the 4 is equal to the splat plus 1 3/4. The splat, the blue circle is 1 whole. The 3 circles with the 3 red pieces each represent 1/4. So when you put it together, and that's where we would want to, so if you can pop back into the Google Meet tab, the one that actually has the 1/4 plus 1/4 plus 1/4 equals 3/4, that's the kind of connection we want to help students in grade 4 to see. That each of those visuals, each of the red colored part represents 1/4. And if we put those 3 together, we get 3/4, 1/4 plus 1/4 plus 1/4, and really showing students that mathematical expression, or equation in this case, because it equals 3/4. And then helping students to think about, well, how much more do we need to get another whole? So you're really developing that fractional thinking, preparing them for operations, but connecting it to the symbolic notation of fractions that they didn't experience so much in grade 3. Great, thank you for your thinking on that. When we get to grade 5, students are adding and subtracting fractions, but it's only with like denominators. So again, this is a Pear Deck text slide. What I want you to think about and share is, how might students represent this problem visually? So I don't want the answer of a picture, because visual infers a picture. What I want is more specifically. So what would you anticipate students in grade 5, what might they do with this problem? What might they draw, or what might they represent concretely? And I'll just give you a couple of minutes to share that thinking in the Pear Deck. Thank you, Hebron. So I'm seeing ideas like an area model, a bar model, fraction strips or fraction circles, how students might have a 7/10. And even, okay, so one of your answers is simply 7 subtract 3 subtract 1. that shows a lot of understanding. And so again, Hebron and I were chatting about this, is how it seems really simple, right? 7 minus 3 is 4 minus 1. Well, there's 3 left. Like, it's pretty simple. But that's because we already understand that tenths are just a unit. It's like saying we have 7 apples, we give 4 away, we give another 1 away.
Mm-hmm.
Students may not have that, well, they won't have the same level of understanding that we do as adults. And it may not be as simple for them. That's where, again, the models are really important. So I'm happy to see someone also mentioned a number line and the number of jumps on the number line. So how many jumps we get to 7, and then if we subtract the 3 that are going to somebody, and then there's another one going to somebody else, how many are left? So again, we just want to reiterate the importance of those visual models, even though to us it seems really easy and we think, wow, how can you spend any time on adding and subtracting with like denominators because it's so easy. It's easy because we have the understanding. And what's going to help our students get there is that experience with modeling it in different ways. So giving them a context where maybe it is an area model context, giving them another context where maybe it's, they're bicycling or walking or running a distance, which lends itself more to a number line or a linear representation. So thinking of those different contexts that help students to use different models to deepen their understanding of what it means, so that we don't get students coming to grade 6 and going, I hate fractions, fractions don't make any sense. We get them coming to grade 6 saying, oh, fractions, I'm good with fractions. It's just units. I understand that. And I know we're probably likely getting somewhere in between, and that's okay too. Okay, again, thank you for your thinking on that. By the time we get to grade 6, students are expected to add and subtract any fractions. So proper and improper, like and unlike denominators. But notice again, using appropriate tools. So as we've said a couple of times, we're not using algorithms. They're not finding equivalent fractions and common denominators. It's using tools and models. And just to emphasize, we do want to stick with those linear and area models. Set models are possible, but the whole needs to change, and that adds a level of complexity that we don't want in grade 6. So we stick with linear models and area models, both visual and concrete, to represent addition and subtraction of fractions. And as I mentioned in the previous slide, depending on the context, if you're sharing a cake versus walking a distance, it's going to lend itself to a different model. Okay, next slide, please. So students are not likely to come up with this on their own. And it's a model, the array model for adding and subtracting fractions was new to me in the last probably year and a half. I was quite familiar with the array model for multiplying and dividing because I taught grade 7 and 8, but not for adding and subtracting. So the way that the array model works is if I want to add 1/2 plus 2/5, I want to take a rectangle because I'm making an array, and I want to be able to show halves and fifths on the same rectangle. So I'm going to partition horizontally to show my halves, and then I'm going to partition vertically to show my fifths. So I've got this array that's 2 by 5. Now I can use different color counters. So I just, again, want to reiterate, it is an area model. Rather than coloring, I'm using these counters. So it looks like a set, but it's not. It's just showing what parts are shaded. So I've got my 1/2 shaded in red, and I've got 2 of my fifths, my vertical fifths, shaded in green. On to the next slide, please. I've got some overlap, and I can't have one of my array cells being 2 colors. So I'm going to move the ones that are overlapped. So if I move the overlapping ones to empty spaces, I now have 9 shaded out of a total of 10. So my answer is 9/10. And students will be able to see that and understand that, and they don't need to think about common denominators. They can count and see, oh, there's 10, that's my whole. It now has 10 parts, and 9 of them are shaded. So my answer is 9/10. So Emily, the way I knew to do a 2x5 array is because I wanted to represent halves. So I split my rectangle in half horizontally, but I also wanted to represent fifths. So I split my rectangle vertically into fifths. So it's a precursor. It's helping students think about common denominators, but we don't want to go there. We're just getting them ready visually and helping them explore so that when they get to grade 7, they'll be well prepared to do those equivalent fractions and common denominators. So this is new, but we're going to give you an opportunity to practice. So Hebron, next slide. We want to give you an opportunity to talk because trying to do something all by your lonesome that's new is more challenging. So in a moment, we're going to put you in breakouts with 2 people, just 2 of you to chat. You're going to click in the pair deck so that you're going to a shared class slide deck. And you'll see that there's sets of 3 slides. There's a title slide that's orange or purple. So you're going to pick a set of 3 that are either purple. The first set's the master. So either the second set is orange and then purple, then orange, then purple. And together with your partner, you can pick the same ones or you can pick 2 separate ones, doesn't matter. You're going to use the array model to add, and then you're going to explore a subtraction. So one of the questions, can you go back to the other tab first, or to the slide deck, Hebron?
Yep.
You can see, thank you. The second fraction is actually subtraction. And we haven't talked about how to use the array model for subtraction. So that's another reason we want to get you together with somebody. Talk about and think about how might you represent that subtraction question on an array. So that's a bit of problem solving for you. The first one is just practice, getting used to the array model. And the second one, we want you to problem solve with your partner. So once we get you set up, we're going to give you about 5 minutes to do that exploration. And again, you'll need to go into the pair deck to click on that link to get to the slide deck. And Hebron's going to put you in partners. Please.
It was
Emily?
so hard to move the counters on top of the tables.
Oh, yeah?
Like when you were originally doing it was fine, but then if you left it and you wanted to come back and move it, it was like almost behind the table. Like it just wanted me to type on the table.
Oh. So you want to move the table behind, like, yeah.
Order it.
Yeah.
Send it back.
Yeah.
Then that way when you click it.
Yeah, now you should be easier. Okay, how many are back, Hebron? Do we have everybody back?
We have all but just a few hardcore mathies. We've got 3 groups that are like, no way, I want
They're not coming back.
and they're not coming back. Like, I can't do anything about it.
That's okay. You know what? I'm going to go ahead and start to consolidate. So we've identified this slide, Emily and Bruce's slide. So Bruce, I'm going to get you to explain your thinking here. Can you tell us what you and Emily talked about for the 5/8 minus 1/4?
Our approach was to set up all the boxes so that we could demonstrate 5/8 and demonstrate 1/4. And then there was the stage where we took the 1/4 counters and matched them with as many of the 5/8 counters as possible. And then we took a look at what we had left over, counters that were by themselves. Okay. And we hoped against hope that the students would figure out that there were a certain number of rectangles in that array, and that the red counters represented a certain number of those total rectangles in the array.
Okay, and because we're talking about grade 6, it's likely that they would be able to if not just directly count, they could figure out, since that's a 4x8 array, that there's 32 rectangles, small rectangles, and that there are 12 of those 32 counters left.
Mhm.
Okay, so I'm going to get Hebron to jump to, I forget which number it was already, Hebron.
I will find it. There. No.
No.
There. No.
Yeah,
There.
the next one. There. Okay, so I believe that's Ryan. Yeah, the next slide.
That one?
Nope,
No.
the next. That. Nope, 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 nope. Back
The
up.
one. The one before. Oh, okay. Okay. Yeah. Yeah.
Nope, you're on 17.
This one.
18. You're skipping it. Nope, you went to 19. 18.
I was on 18. There we go. Aha! I was on there. It's just delayed, right? So when I'm here,
Oh,
you go next. It's like,
yeah.
okay, we got it. We got it.
Okay, so this was Ryan and Minsu. So does one of you want to share your thinking here? One of Ryan or Minsu?
The reason that we did not choose 32 is because I think for the denominator as s, it's very easy for them to see from these 8 boxes. And then
Right.
for 1/4, it's also the same, because if you take away one row, it's going to be 1/4.
Great. So just paraphrasing what Minsu's saying, I agree. Students, what we want with the array is we want to be able to see both 8ths and 4ths. And so in the way that Minsu and Ryan have arranged their array, we can see both 8ths and 4ths. And that's the key. So there's no right answer. Having 32 sections, partitions, is correct. Having 8 partitions is correct. Having 16 partitions would be correct. It's whatever makes sense to students. And being able to show both of those fractions. So showing the 5/8. Now, we actually don't need a second color here. So we could have 5/8, and then just visually, the students could see that 1/4 is a whole column. They just take them away. And we're left with 3 red shaded spots. So again, whatever works for students to make sense of that array model. Okay, so I know that was just an introduction, and it's one that is a useful model, so hopefully you can spend some more time familiarizing yourself with it, and then introduce that to your students, because it's not one they're going to just come up with. Thank you, Hebron. Next slide. Okay, we're going to use a waterfall strategy here. Just a reminder that the waterfall strategy is that in a moment you're going to answer this question in the chat, but you're not going to press enter or return until I count down and say the word waterfall. Then you'll press return. So in the chat, I want you to type what fraction expression, and you can type 1 or more, do you see in this image? So I'll give you a few moments to type a fraction expression in the chat, but don't press enter yet. Okay, and now I'm going to count down. 3, 2, 1, waterfall. Oh, I like that we're getting a lot of different expressions. That's wonderful. So I'll invite you to just have a quick look in the chat to see what your colleagues have come up with. Claudia, I see your hand, and I don't know if you want to add to this discussion or if you have a question.
Oops, sorry, that was from before. My apologies.
Okay, sorry. Okay, so Brenda, can I have you tell me more about what you typed in the chat?
Oh, so a third plus a third plus a third is a whole. So I felt like I was looking at the whole set and that they were sort of touching together at the top. So that was like a third of the set, and the middle was a third of the set, and the bottom was a third of the set.
Great. Thank you for explaining that. Ryan, can you tell me about the fraction equation that you wrote?
I guess I considered each row to be 4 of a potential 4, and so 3 times 4 fourths is 12 fourths.
Okay, can you tell me more what you mean about 4? Like, where is the 4 coming from?
Like, there are 4 quarters per row, 4 quarters of a tomato per row.
Okay, so you're seeing that a tomato has been partitioned into 4 parts, and so in that first row, that's a whole tomato, potentially.
Yes. Yes.
Okay, great, thank you. Just gonna look, see if there's anyone else with a significantly different. So different people had variations on those two. And in this visual, we can actually look at it from the standpoint of grade 4 and just making the connection. So we've got a fourth plus a fourth plus a fourth plus a fourth on that first row gives us the 4 fourths. And then we could go like, we could be counting like 5 fourths, 6 fourths, 7 fourths, 8 fourths, 9 fourths, 10 fourths, 11 fourths, 12 fourths. So making that connection in grade 4 between unit fractions and the fraction that it makes, so 4 fourths being a whole. In grade 5, we could be adding those unit fractions to get 12 fourths and making a connection to multiplication. And similarly in grade 6. And in grade 6, we would not necessarily have the unit fraction. So it would be more like Minsu wrote 4 twelfths plus 4 twelfths plus 4 twelfths, which is the same as Brenda, but Minsu's seeing them as individual pieces and they're not unit fractions. Okay, thank you for your thinking on that. Just to clarify and reinforce, in grade 5, students are multiplying and dividing a 1-digit whole number by a unit fraction, only unit fractions. Again, using tools and drawings, so not strategies and algorithms. So in this particular drawing, this might represent 1/3 times 6, or it might represent 2 divided by 1/3. In other words, how many 1/3s are there in 2? So showing students a visual like that and just having them think about, like we just did in the previous slide, what fraction expressions do you see? And in grade 5, the emphasis is on unit fractions, even though students might see, 3 groups of 2/3. That's fine. They can see what they see. But for teaching purposes, the emphasis in grade 5 is on multiplying 1 digit by unit fractions and dividing 1-digit whole numbers by unit fractions. Then into grade 6, we are now multiplying, dividing any whole number, but we still want it reasonable. So we still want whole number answers. We don't want fraction answers. And it is specific in the curriculum that we want whole number quotients when we're dividing. So when we think about, and the link on this slide is to the virtual tool that allows you to have this number line with the fraction pieces, because that's a really good visual for helping students, whether it's multiplying. So we've got 5 2/5, and what does that equal? Or dividing 2 wholes divided by 2/5. How many 2/5 are there in 2 wholes? So emphasis on tools and strategies. And in this case, the strategy might be repeated subtraction. So I'm going to subtract 2/5, or repeated addition if it's multiplication. That might be the strategy, but still an emphasis on those visuals to help students make sense of what it means to multiply a whole number by a fraction or to divide a whole number by a fraction. Proper fraction, not improper. The strategies that students use, similar to when we talked about adding and subtracting, are going to depend on the context. So one of the contexts we want students to be exposed to is scaling. So for example, 5 times 3/4 may be interpreted as the total number of unit fractions is 5 times greater. And we want kids to be familiar with that language being 5 times greater than. And so that's one context for multiplication of a whole number by a fraction. If the situation involves equal groups and its division, we might have 24 divided by 3/4, and we might interpret that as how many 3/4 are there in 24. So I've got like 24 meters, and each ribbon that I'm making, or each bow, or each project that I'm making takes 3/4 of a meter. How many of these projects can I make? So considering all of those contexts. No, that's good. Go on. Go ahead, Hebron. Okay, so that brings us to sample weeks at a glance. So as we've been doing, we have a sample. We've done it a little bit differently this time because there's so much content in topic 11. We actually have a sample week at a glance just for operations with fractions, and we have a separate one for the rate ratio content. So just as we did before, thank you to Heidi Schreier. She has translated, for the French immersion folks out there, all of the tasks that are in these sample weeks at a glance. And the French is not linked on this slide, but that little Francais symbol is linked on each of the weeks at a glance. So we're just going to have a quick look at the grade 5. And what I want to highlight is, again, we're looking at about 3 days that we're going to focus on number talks, looking at connections between the visual and the symbolic like we do in grade 4. We're building on that in grade 5 and representing that addition of unit fractions, connecting it to multiplication with those fraction splats. And then scrolling up, Hebron, or down, or whatever way you call that. I wanted to show the grade 5 because you can see that both the tomatoes on the cutting board and the number line showing the jumps of a third are minds on task for 2 of those days. So there's something that you're now familiar with that you might use with your students. Similarly, on day 2 is the question about the 7/10 of the large cake that Alex found, and she's giving some to her friends and taking some for herself. So a lot of the questions we used today were from the grade 5 week at a glance. And then just back up to the top there, Hebron, just if you hover over that Francais, you can see that that links to a folder with all of the translations for all of the student problems in that particular week at a glance, and each of the grade 4, 5, and 6 has that. Any questions about the operations with fractions? Easy way to copy and paste the Google Drawings. So what we found, Emily, is that you have to actually open the Google Drawing and take a screenshot, because, yeah, don't take a screenshot of it in the week at a glance. Like, open the Google Draw, then take a screenshot, and then it's not as blurry. Because it is blurry if you just take a screenshot of it in the doc. I hope that makes sense. There are some questions like this on the way. You create for, can you speak to that? Are we introducing it in grade 4? Oh, so the visual, again, in grade 4, it's about counting. So we're counting by unit fractions in grade 4. So those visuals are all about counting by, I think most of them are fourths there. And you can see counting by unit fractions and connecting it to, you know, multiplying. So there's 1/4, 2/4, 3/4, 4/4, and just really reiterating that for students to help them understand beyond one whole, 5/4, 6/4, 7/4, 8/4. The multiplying would be, I have 4 1/4 in that one piece of, I don't know, is that bread?
Looks like some kind of bread, yeah.
Right. So I've got 1/4, 2/4, 3/4, 4/4, or I can think of that as 4 1/4. If I look at the 2 slices of bread, I've got 8 1/4 is equal to 2 wholes. I've got 12 1/4 is equal to 3 wholes. So that's that connection to multiplying. There's no actual, we don't give them problems where they have to multiply. It's really about counting and connecting. That's all. Any other questions about the operations? And if they come up, feel free to throw them in the chat, but Hebron's going to take you on another journey now into rate, ratio, and percent.
Wonderful. So the second half of topic 11 is looking at rate, ratio, and percent. And to start off, we are going to do a waterfall like we just did. I'm going to give you this prompt, a would you rather prompt. I'm going to let you think about it. And then you're going to pick, would you rather share 12 cookies with 3 other people or share 9 cookies with 2 other people? Jot down your response to that. Don't press enter yet in the chat. And we will do a 3, 2, 1 waterfall. I'll give you a moment.
And maybe include some of your rationale.
Mm-hmm.
Not long-winded, but just maybe a little.
Okay. I think that might be enough time. All right.
Sure.
So, sure. Ready? Okay. So 3, 2, 1, waterfall.
Interesting.
Fantastic. Okay. Megan, do you want to talk us through your response?
Absolutely. In both cases, when I'm thinking about 4 people sharing 12 cookies, I would get 3 cookies because it'd be 3, 8, 3, 6, 9, 12. If I skip count by 3s, I would still get 3 cookies in the first one. In the second one, if I have 9 cookies, I can skip count by 3. Also 3, 6, 9. So both cases I get 3 cookies. So same for me. But in scenario number 1, more people get cookies. 4 friends get cookies. That makes more people happy. So
That's fantastic. Very interesting perspective. All right. Thanks, Megan. That's great. So people saw that you're sharing the cookies with other people. So there's, in the first instance, there's 4 people sharing cookies. In the second instance, there's 3 people sharing cookies. And you are doing some splitting. Maddie's used some fractions in her splitting. I get 3 cookies, a quarter of 12 is 3, and a third of 9, which is a good connection piece there. The big picture we want to focus on here is that in grade 4 specifically, it's really about just showing and thinking about simple rates. So instances like this is engaging them in contexts in which they can get, your students can get involved in dealing with that. Whole number rates. We don't want them to do any formal dividing. We want them to be representing and using those models and thinking about it and making sense of it, just like you guys have done so wonderfully. All right. We are going to go into breakout now, just for another 3 minutes or so, a little bit shorter than last time. I want you to go in the breakouts in the same groups and determine the 2 different unit rates for each option in this situation. So for each of the options, there's 2 different unit rates you might determine. What might that be? So I'm going to send you out to your breakout groups. Let me know if you have any questions. Set up rooms. Set the timer for I'm going to do 3 minutes for you to talk it over. Ready? Off you go. Sorry, Claudia.
Well, Claudia, you can talk to us if you want.
Yeah, actually, that would be great.
Sure. I was just getting a phone call at the same time. I don't know how any of this works, but anyway, I just ignored it. So what was the question again? Sorry. Oh, unit rates. So is that like we could talk about 12ths and 9ths? Is that what you mean?
Well, you tell us. Why does that make sense to you?
Yeah.
Well, I don't know. If I'm talking about 9 cookies, then I want to talk about 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9 until I get to 9/9, and then take 1/9 and give it to one friend, 1/9 give it to the other friend, 1/9 give it to the other friend, and do that until I run out of 9ths, or the same with the 12 cookies.
So it sounds like you're making a really good connection to operations with fractions or just to fractions, and you don't need to. I think you're making it more complicated. So we've switched gears. You don't need to think about fractions anymore. I mean, you can, but it's harder now if you think about fractions. So just think about the whole numbers. And like a unit rate, for example, would be so many kilometers per hour.
Yeah. So it'd be per 1.
Here.
Oh, like so saying like 3 cookies for one person,
Yes.
and then 3 cookies for another person,
Right.
and 3 cookies for another person.
Right. So that is 1 unit rate. What would be a different unit rate in that same context? So let's look at the 12, okay? So 12 cookies with 4 people is 3 cookies per person. That's 1 unit rate. What's another unit rate in that situation? And that's the hard part. That's why
I know.
we're in breakout rooms to talk about it.
Okay, go again. Say that one again. Say that one again.
So what would be another unit rate? So we know 3 cookies per person is a unit rate for that top example. What's a different unit rate for that same situation?
Can I double it, like 2 for 6 people? No, 1.
10, but that's the same unit.
That's a rate.
Yeah, it's
That's
no
the
longer
rate. It wouldn't be unit rate.
Right. No.
Um,
I'm with Claudia. I'm stumped.
Yeah, I think I'm just not understanding the question.
Okay, so think about what a rate is. A rate has 2 different measurements, right?
Yeah, something to something.
Mm-hmm.
Right. So we talked about cookies per person. What's
okay? So you mean like 3 to 9, like 3 cookies? Sorry, 3 people, 9 cookies. So one person to 3 cookies, or 3 cookies to 1 person, or 6 cookies to 2 people, 9 cookies to 3 people.
Those are all equivalent rates, but only one of them's a unit rate.
Because it has to have.
Okay. We've got people back, Hebron, so I'm going to let you. I'm going to stop talking.
No problem.
Me
this
too.
is great. No, I love the discussion. So what we were just discussing with Claudia, first we had to kind of decide, what do we mean by unit rates? Would anyone like to speak to that? What do we mean by unit rate? We know what unit fraction is, but what is a unit rate? What do we mean by that?
Wendy has her hand up. Yeah, Wendy, go ahead.
I was going to say what Ryan just said, like a per one of some unit. So how many cookies per one person, or how many people per one cookie? Those are both unit rates, right?
Yes. So the challenge was, you had to find out what were the 2 types of unit rates you might come across. And I think Wendy was speaking to it. Do you want to continue, Wendy, explaining your thinking there? What were the 2 that you mentioned? There's 2 unit rates you mentioned.
I said the number of cookies per one person or the number of people per one cookie?
And what is that rate? What is the number of people per one cookie?
Number of people per one cookie would be 3 people to one cookie. Now I got myself confused.
I expected that, sorry.
Just set you up. She's like, no, that, so
okay.
you're on track. So the idea of a unit rate that we're used to, that cognitive, like that makes sense, is cookies per person, because we're looking at it individually. So we get 3 cookies per one person. But we were just pushing your thinking a little bit, because there are contexts in which, now this one's a bit of a stretch, but there are contexts in which the unit rates can be flipped. So in this case, you're looking at people per cookie. So instead of going cookies per person. So if you have 3 cookies for one person, how many people would get, what would be the people per one cookie?
Yeah, cookie. Yeah, that makes sense.
So, and the idea is,
Wow,
that,
I never would have gotten that. Sorry.
no, and that's not the point. The point is less about this context is a stretch. The point isn't to necessarily get the number, but for us to realize, oh, when we're dealing with rates, we can have, for example, kilometers per hour, but we can have hours per kilometer, and we're not used to. We don't give enough opportunities for students to engage in flipping that. So that's something to think about when you're engaging in rates, that there are contexts, and I wouldn't do this in grade 4, right? Grade 4, you're just dealing with representing very simple whole number rates in contexts that fit. But when you get into grade 5, and especially when you're doing rates that deal with best value, you might look at values that are listed in dollars per kilogram. Sometimes you might look at kilograms per dollar, depending on what's going on. 1 to 3 and 3 to 1. Yeah, and those ratio rates would connect as well there.
But wait, they're not the same. But 1 to 3 and 3 to 1 are not the same, because the order and a ratio matters.
Matters, right? Yes.
So those are definitely not equivalent. They're not the same.
Unless you're like labeling. Well, no, even then, no.
No, it's not. But just one other point of clarification: every situation that has a rate has 2 rates. It's just like Hebron said. Sometimes they don't make any sense, but it still exists. Like this one, it doesn't make sense. Like how many cookies per person makes sense. How many people per cookie doesn't make any sense, but it's still a legitimate unit rate in this context. And that's important for us as educators to know, not necessarily for especially grade 4, but grade 5s could explore that, and grade 6s could explore.
And I would also like start with contexts. I know Wendy has a question. I would start with contexts in which both would be working. I wouldn't jump into a context like this, perhaps. The dollars per kilogram, dollars per value, that usually is flippable, because you're in comparisons in that unit rate both ways would work. Wendy, you had a question.
I remember a question about McDonald's coffees and which was the better deal. And I remember calculating it 2 different ways to find out how much money you paid per milliliter and how many milliliters you got for $1.
Right.
Yeah, that's a perfect context in which they would be comparing both ways, and it's good to expose them to that, because we tend to get stuck in one way. So the 1 does not have to come first in a unit rate.
In a unit rate, the 1 comes second.
The 1 is second.
Always second. You just have to flip the per cookie or per person, per kilogram or per dollar. You just would change the way you're listing it, but the 1 would always be the second number.
Which is why we can use the short form, like kilometers per hour, because it's, it'd be like, 100 kilometers per hour, because the 1 is understood, because it's a 1. Like we could say 100 kilometers per 1 hour, but we don't need to. It's understood when it's a unit rate. So the kilometer/hour, the 1 is understood with the denominator, with that second term.
Cool. That was fantastic discussion around that. We were hoping for that too, so it was great. So when we're in the grade 4 curriculum, again, we mentioned this, we're showing simple multiplicative relationships. So when you look at the week at a glance, you actually see some multiplication starting off that week. And then we're looking at whole number rates, and we're representing it and showing it using tools and drawings in various ways. And this particular example, we have, how much it will cost to get to, you might prompt your students, how much is it going to cost to get 2 packages, 4 packages, and they don't necessarily, there's no mention of unit rates in the curriculum for grade 4. They don't have to go to a unit rate. They can compare using any kind of rate. So we've got $8 per package, $16 per 2 packages, which is also a whole number rate. So they can still use those values. And they're actually not comparing as well. I just wanted to clarify. They're just showing, representing. All right, let's jump into this question here. This is a 3-2-1 waterfall. Again, we have a bunch of those today. You need to figure out how much 8 boxes of cereal cost. So here's a pile of 8 boxes. What information below would be most useful to you? And to try to explain your choice in your waterfall. Again, a little blurb, doesn't have to be long. Option 1, how much 1 box costs. Option 2, how much 3 boxes cost. Or option 3, how much 4 boxes cost. Okay, I'll give you a moment to write that down, and then we will jump into our 3-2-1 waterfall. Okay, that's probably not enough time, but 3, 2, 1, waterfall. Awesome. So I see a number of people going, hey, how much 4 boxes cost? Because I can double it. It's a good connection to 8 boxes, right? 1 box cost would be useful as well. I see a couple of those. So that being said, which one? The one that I don't see is the 3 boxes, because it's kind of not useful because it doesn't get me to 8 multiples. So it's a good variation of responses. How about if you had 5 boxes of cereal now? Now you need to figure out 5 boxes. How's that 4 working out for you? That's just me. That's just us being silly. It's mostly me. Basically, there are times where we want to use a unit rate. We tend to, in our kind of default, want to square things up, go one way or the other. But we want our students to recognize, hey, sometimes you just want to use a rate. If I know 4, I'm good to go. I can go 8. But sometimes we want to use unit rate. And we know for sure, actually, 100% of the time when we're doing rate comparisons, unit rates will get us there. It doesn't mean we want kids to blindly be using unit rates all the time, but we know it'll work. So there are times in which just knowing 4 won't work if our situation changes. Anyway, that was the point of that slide. Not important.
No,
Michelle?
just fun. And they have answers. Like Emily's like, fine, I'll just divide by 4 and then multiply by 5. So
Yeah. I got my unit rate now. Okay. Awesome. So in the grade 5 curriculum, they create equivalent ratios and rates using, again, tools and models in various contexts. Really important. And they do have to calculate unit rates and identify which rates offer the best value. And that's from a financial literacy piece. One of the things we want to emphasize here is there are 2 different kinds of unit rates, like we talked about. It's good for them to be exposed to that. And the fact that using ratio tables, we're going to talk about it next, as a tool to organize and solve to find unit rates as well is important. Like in part C, we're forced in this example in part C to find a unit rate because we have 54 books and fit in 6 boxes. So 12 boxes is good. 3 boxes works. 5 boxes, we need a unit rate, right? And in grade 6, we're working to solve problems that involve ratios, percents, rates, using tools and strategies. And one of the tools and strategies that we have here is a ratio table, which is it's very helpful, especially in this setup, because I've used ratio tables before in various ways. You don't necessarily need to have all the A, B, C, D labels, but they need to have some organizational flow of thought between columns here, the way it's set up. So you can see that in the bottom row, their thinking is shown by referring to the columns. So for example, here, we've got this ratio situation where we have yellow beads, red beads to white beads for this bracelet. And we are trying to perhaps figure out a bracelet that has 30 red beads. What are the other proportions? What are the other beads that we need if we need 30 red in this situation? So organizing it in these columns helps because you can actually help students organize and reference their thinking. So in column B, we're going to take on the bottom, we've said, okay, I'm going to take column A and I'm going to divide by 3 because I see that each one has a multiple of 3. So 9 becomes 3 and 6 will become 2 and 3 will become 1. So this is a really cool way of organizing things, and I'm sure students can have their variation, but the top row and the bottom row are actually something that was relatively new to me, and it's very helpful in tracking my thinking as I go across my table. And the fact that I can keep adding those rows and keep working across to get what I want. Also, another thing we want to mention is that you can skip around. It doesn't have to be perfectly done in order. So let's say 30 was something we were trying to get to. We could have put 30 in column B and said, you know what, I can't go from 9 to 30. I'll probably need to do it in steps. So then column C could have been, hey, I can go from 9 to 3 and then from 3 to 30. So I can put 3 in column C. So it doesn't have to perfectly go in order. But then on the bottom, you can track what you're doing. So I'm in column C, I'm actually going to take column A and divide by 3. And then column B would be blank because I want to get to 30. So that's okay. And then the next column, I'm going to take column C and maybe multiply by 10 to get to 30. So, and then when they're sharing their thinking with other students or with you, they've kind of tracked what they've done. That was one thing that we had trouble with our ratio tables. They might get kind of big and going down and, oh yeah, this is what I did here, but I kind of forget and I have to talk through it instead of having those steps outlined. So do you want to, yeah.
Yeah, just a couple of things. So Emily asked a question, and it's a really good question, Emily. So she's wondering, would E then be A times 3 plus 3? So the way that ratio tables work is they're always multiplicative. We wouldn't have a plus 3 ever. So because we can't get, like, if we wanted to go from A to E, it would be times 3 1/3, which we also are not doing with rates in grade 6. So that's why we use the ratio table to break it down. 2 other things. Grade 6, they introduced the idea of a 3-term ratio, hence the yellow, red, and white beads. So these 3, the yellow, red, and white beads is right from the curriculum, but this particular table is a table that I just created for a problem in the sample in the week at a glance. And the problem is if there are, I can't remember the number, something like 456 beads in total, how many yellow, how many red, how many white? So they have to use that ratio table to try and figure that out. And it's a way to introduce a ratio table because, again, it's not something students are going to say, oh, hey, I'm going to create a ratio table unless they have exposure to it. So by presenting a ratio table and asking them to fill in to try and help them solve, you're introducing the tool that helps them to think, and it's always multiplicative. So
Yeah.
E, I mean, there's different ways, Emily. I could look at B and I could multiply B times 10. Or what you can do, and this gets confusing, but it isn't confusing, I can add columns B and D. So I can add entire columns because I'm maintaining the multiplicative relationship, but I can't multiply and then add across. So E could be column B times 10. What is C going to end up being? 18. Yeah, that's not going to be helpful.
Yeah.
But I could also get E because when I do the white beads, it's going to be a 1 in column B. And so, yeah, it's times 10. Like that's the easiest, B times 10. But there's lots of different ways.
Yeah, and it could be a scenario where you're trying to find 45 red beads, right? And then you might do some multiplicative relationship where you add the 30 and the 15 or something, right? But you're right, whole columns at a time, because they're proportionally growing together. Taking two proportions and putting it together.
Right. And so, yes, Emily, you can't skip to E, even if you want to. Like, kids can't go from A to E because, I mean, that's not true. You can, and you may have a keener in grade 6 who says, well, that's, 3 1/3 times, because I know it's 3 times and then 3 is 1/3 of 9. So it's 3 1/3 times. Okay, that's your outlier. Most kids are going to take several columns, and that's the beauty of a ratio table. They don't even have to take the same journey to get there, but it has to be multiplicative. So they can multiply or divide, and then they can add columns or subtract columns.
And I don't know if this was set up to be like a bit of a way of getting them used to using a ratio table, as having some of these blank pieces, and it could just be a non-contextual ratio table that you're just filling out, right? And the given at the bottom will indicate what might be going in that ratio table, or the 27 or the 30 or the D divided by E. So
that's a plus.
Is it a plus? Oh yeah. It's really tiny from where I should be wearing my glasses, guys. I know. But the organizational piece is what I also have really appreciated, the top and bottom rows to show student thinking, which is important. All right. That being said, we're going to give you a go. We've got a situation here. I'm going to read it to you. Navin and Bea are coin collectors. They recently sold 16 of their 25 coins from the UK. Which percent of their UK coins did they sell? So we're looking at 2 ratio tables. Which ratio table makes the most sense to help you solve the problem?
And that's a paradox. So
you can pop in a text.
Okay, that's fair that for some of you, the ratio table is still like tricky. And that's totally fair, because if you've never used one, it's an awesome tool though. So I would encourage you to become familiar with it, because it's one of those tools that has legs that students can use throughout their high school, like grade 6, 7, 8, 9, 10. It has legs. It's really a valuable tool. So yeah, I would recommend you become familiar with it.
Yeah, any kind of multiplicative thinking. So I've used ratio tables for multiplication, division, rates, ratios, and percent. So any of that stuff is really useful. Okay, so I'm seeing people, some people like the vertical structure, which I was trying to think about which one I had an affinity towards as well. And for some reason, that one tended to be it.
I think everybody has the second one. Everybody's chosen the second one.
I don't know why, but the reality is both are great. it's important for students to have that flexibility to use the tool to represent it whichever way they see fit, and whichever way is, appropriate for them. You can see that you can use the top or the bottom one to figure out that relationship between 25 and a whole being 100, whether you're going across or down, to get that multiplicative relationship to 25 to 100. So it's important for students, once they've played with the tool, maybe given those fill-in puzzlers in various contexts, to have flexibility to use the ratio table and share how they've used the ratio table with one another in your problem-solving scenarios.
Just before you go away from there, Hebron,
yeah.
The top ratio table, even though it isn't as attractive to you to use, Math Up uses a double number line, where the coins in this case would be on the top and the percents would be on the bottom. So the top ratio table more resembles a double number line strategy or model, and the bottom one more resembles a typical ratio table. Both of them are fine, but just know that in Math Up, Marion doesn't talk about ratio tables, even though the curriculum does. She talks about double number lines.
Yeah. Awesome. So we do have sample weeks at a glance for rate, ratio, and percents. I'm just going to show the grade 6 rate, ratio, and percent. Because some of the ratio table situations that we've talked about are in here. So that week at a glance will help you and your class walk through and use some of those ratio table tools, which would be very useful in grade 6.
And also those math talks you're going to talk about.
Yes, and the math talks. So we've got percents of math talks for day 2 and day 4 that are, they're great for them doing some mental math, which is in the curriculum for them to work through getting percents of friendly numbers, and reinforcing fluency in that multiplicative thinking. So, when they're thinking about 10% of 360, them thinking about a tenth of it, a place value, connection, half of 360, 50%, those things, math talks are really helpful. All right, so I'm going to go back to this. And we would love, that brings us to their last.
Our slide says next session's on March 16th.
Oh, yeah, we should have. I got to update that. I'll do that right now, actually. We would love to get your feedback about this session in this text slide, Pear Deck. And then if you have any questions, you can stick around. We will definitely address them with you. But if you have to run, thank you for sticking around with us extra late today to talk about rate, ratio, and percent on top of our operations with fractions. We've had a great time discussing those things with you.
Yes, thank you very much for the additional time in an already busy time. We really appreciate your commitment to your own professional learning.